Well, hi, good morning. Thanks for joining me in my shop here. Big difference 2 days makes. So I was in my shop yesterday, but I didn't post any videos because as soon as I got working in here, I decided I needed to go through my meager transistor stock very thoroughly and look for some replacements for the original transistors that are in this unit here. Here they are down on the piece of paper here. These are the two incorrect substitutes that I took out where it looks like the terminals might have been shorted. Okay, I can only put it that way. I think they were shorted, but some of you don't. In any case, these are not the right transistors. These are the correct transistors. These are 2N901s. They came out of the unit. Today I'm going to be repeating some of the tests I did yesterday. So I already know that these two guys test okay. One tests a little better than the other. So we're going to repeat these tests to be more sure of it. What I discovered that surprised me, contrary to what I had discovered earlier, is there is a replacement transistor for the 2N109s, and it's a NTE or ECG 102. And guess what? I got a bunch of them. So I got a bunch of them. 1, 2, 3. This bag's empty because the two that were in it are down here in my very clever tray I've set up. Isn't that clever? So yesterday I got to the point where I had 4 apparently good working transistors, and then I just stopped because the weather was so great. I went outside and didn't post anything. So today I'm starting from there. We're going to repeat the transistor test. We're going to plug those transistors back in here. That's a bit of a challenge in itself, especially for these ones, as I have to get the base emitter and collector correct, and that's just a little bit of a challenge in there. To help with that, I've made this diagram. Don't know if you can see a little circle there representing the transistor with the 3 leads, and this one represents these transistors whose leads are in line. These are inline leads. That's where we're at. So why don't we start with testing these. I'm using this instrument here. Instrument that would make any electronics guy pretty lazy pretty quick. So I'm going to hook. So to identify these two separately, I'm going to put a dot on the top of one. Try anyway. Okay, that's enough of a dot. This very clever instrument here. I just hook up these 3 test leads. Short there. Any which way, it will tell me, it will figure out which one's on what collector emitter base. Okay. Original dot. Better pen here. That's not going to last long. Here we are. Okay, so HFE50. 215 millivolts. That's the drop across the junction, I believe. 215 millivolts. That's typical for germanium. And then current flow. Oh, base to collector disappeared. Let me get it back up there again. When you repeat these tests, they don't come out exactly the same every time. So current flow. The 2 current flow measurements are very low, 0.08 milliamps. Man, that's a tiny current, and nothing. That's a little unnerving. Nothing. I don't remember that happening. Maybe these connections aren't 100% here. Let's just work them a little bit. Try it again. Oh, it was flipped. Okay. Same thing. current flow from collector to emitter. S, I'm guessing means shorted. Don't know what that really means. 0. Okay, so that's the story there. I don't like the 0. Maybe I'm wrong about both these being good. That's why I'm repeating this, because I was doing it very quickly. You know, taking that peek. So I'm going to dip your toe in the pool. See what the water temperature is like. Today I'm jumping right in. Okay. Oh, very, very similar. So this is the one without the dot, 22 point, quite different, 0.22, 0.01, the 88 for the HFE, and voltage is much lower. That's really quite low. I thought it was always around 0.2. So 138. Let's just try that again. Very similar. Okay, so again, I'm not sure what to what to make of that. I think these are both functional. I think if you get a an HFE of some reasonable number, I think you're good to go. Okay, so these are the potential replacements. One of them I have to dot. Two of 5. So I went through my solid state inventory, just the signal transistors like this one. Yesterday I bought a bulk inventory a couple years ago. Never really went through it. Went through some of it yesterday in detail. I have 600 transistors and 60 different types of transistors. It's pretty good vintage stock, actually. Really, not that I do much with transistors. Okay, so here we've got HFE of almost 100. 94. ICE 0 is 0.25 milliamps. 0.02 and 108 is the drop across it. Wow, that's even lower. So it depends how much current you're putting through the junction. That depends upon, it creates the voltage drop across the junction. Exactly what this guy's doing, I don't know. And here's my other potential replacement. Maybe I'll put 4. I should put 4 of these in. 4 of these, 4 in. Maybe 3. Maybe I'll find out one of these originals is good enough. There we go. I also want to make sure these replacements are okay. So now we're up to 100 on the HFE. 113, 20, 0.2, and 0.01. So when I look across these 4 sets of readings now, it's quite clear that the very first one I tested is testing quite different. It has a low HFE, and has a 0 current being found in this test, whereas the others have a tiny current. And this thing's reading a very low current, 0.08 milliamps, so these are all reading about 1/4 of a milliamp. So I think this first one is out. So I need another new one. This is still sealed right in the package. Sometimes these packages are no, these are brand new, sealed in the package. They made it all the way to here, and now I'm going to open it as soon as I can. Having done, 3 of the 4, you'd think I'd want to do the 4th one too. Well, we'll compare the results in the end and make a decision whether I want to stick a 4th one in. Nothing scarce about these transistors. They're easily available. And I may very well have many more potential replacements. And maybe like a recommended replacement. This is a replacement designed by a company to replace numerous earlier transistors. So this one has a broader range. The reason it has a broader range is it can take more current, it can take more reverse voltage, it can take a lot more punishment. It's a newer transistor, newer design. So this one replaces many earlier ones. That's what makes the whole thing so confusing. Well, there are other transistors that are even more strong compared to this one that could be put in there if I care to hunt them down. So I'm not so worried now about, transistors are not like tubes. As a buddy of mine was reminding me, to a large degree, the operation of the transistor is controlled by the circuitry around it. I put in varying transistors and get the same result in the circuit. And I don't think you can do that with tubes too much. A tube varies a bit, the circuit results will vary a bit. Is all that true? I don't know. Okay, here we go. Why am I doing this? Yeah, this is the next. This is number 3. Jim, come on. NOS, no dots. 93. That's a good sign right there. 103, that's another good sign. 33, that's another good sign. This is like Mr. Keyman transistor. So this one tests just fine also. You can see a variation between them. These things are old, even though they've been in a bag. I better put 2 dots on here, or I'm going to get these mixed up. I just want to make sure I keep track of who's who while I'm doing this. And 2 dots. So I didn't bother noting down what's what on this in terms of, I'm going to put this back on, and we're going to identify collector, emitter, base, because I didn't do that. In my own view, transistors are really not that exciting. You can do exciting things with them, no doubt about it. We live in a world that's exciting because of transistors. But as a device, they're really kind of simple compared to a tube. So 1, 2, 3, C, E, B. So number one is the collector. Number 1 is the one out on the, okay. And then number 2 is the emitter. Number 2 is the other one way out down there. Emitter, base in the middle. Okay, that's good. Likewise for this guy now. I guess you could look this up on the internet. There are all kinds of sources that would tell you what the pinout is on a transistor, but this little machine will do it too. Okay, so number 1 is the collector. Number 1 is the, I have to get this triangle right. Number 1 is the collector. So the collector is here. Number 2 is the emitter. Number 2 is the emitter. That's the other side of the triangle, and the base in the middle. I guess maybe it kind of has to be that way. It kind of has to match the pattern up here a little bit, I would think. And base in the middle. Okay, hopefully with that information I can figure out how to plug them into the actual amplifier. Is that kind of where we're at? I'm going to do another comparison here of the potentially, okay, this is the non-dot. The original non-dot is the better one. So it is weaker than the rest in HFE, 88 versus 95 and 100. It's not much difference, really. Again, the circuitry will control a lot of the operation. And the gain is even, I think the circuit gain is controlled by the circuit arrangement itself. So the the voltage drop across the junction is 100 millivolts, 100 millivolts, 100 millivolts, 130 millivolts, 140 millivolts. So it's a little higher here. Yeah, that probably is just showing wear. I don't know. Transistors wear inside. I don't know if they really wear as such. I suppose the chemistry could change over time. They've got a couple different materials pressed up against each other. They're fused in there. Maybe there's some material thing that happens and that. Okay. And what else about it? The so I looked at the junction voltage. The junction. Yeah, what am I talking about? Junction voltage. I just lost my mind here for a minute. So these two currents, I think this is IC base open. No, yeah, base open and base shorted. I think. I'm really not sure what they're doing here, but we can compare them anyways. So 22 compares favorably across there, and 0.01 does too. So I think one of the original transistors is still functioning fine, and it would be the one without the dot. That's this one. Where the other one went, I don't know. It's gone away. So here's our 3. There's our set. There it is. Guys, you're going to get us through. Next stage is to figure out how to plug them in here. Okay, let's do that. Okay, I got it flipped over. Sockets are here. I'm going to switch to another camera. We look right down on it, and surprise to me, the top of this connector does not look like the bottom. So yes, maybe those of you who said, Jim, there's no problem with how those leads were bent on those transistors, it could be quite right, because these are perfectly in line here, but underneath, when you look at the socket, it's a triangle. That's my excuse for being a little confused. So it's pretty obvious how these guys go in. Now, which channel? Should I put it in the channel we're trying to make work? Yeah, why don't we do that? So I'll plug this. I'll make it transistor number 1. Look at that. I can see clearly what I'm doing. So the guy plugging in the other transistors, unless he was doing it in the dark, he should not have got these. We'll experiment with those other transistors here in a sec. Yeah, you can't get these wrong, Jim. These are the ones designed for the socket. It's the other ones. In you go. There it goes. Yeah, once it's seated all the way down, you really can't see how it was done. Let's fool with where'd they go? Here they are. So these are the ones that were plugged in. So I'm going to guess what happened here was it was an attempt to plug them in properly. See, this one would go nice. This will go right in. But this one, no. The leads are right together. You know, unless somehow when I pulled it out there was springiness in them and they sprung together, it really looks like it was in wrong. When it came out and I looked at it, they were right in contact like that. So I'm going to go with that story. I'm going to go with the story that these are the only replacements somebody had, and they're not very good anyway. Apparently, not very good. And they got one plugged in right and got the other one plugged in wrong. It doesn't matter now because we're going with totally new ones. Well, totally new old ones. Now, I'm not going to cut the leads on these. I'm going to let them stick up for now. And let's see if we can figure this out. So if I wanted to write base emitter collector on here, it's quite easy. Let's do that. Let's just do that. So I can find some tape. Here we are. Just do this beside one of them. Put that on light. Lightly. And it's quite simple. EBC. E B C. Do you know your EBCs? Okay. Now, taking this transistor up from underneath. So the base is in the middle and the collector is going to be like this. So this is the way. A long spidery thing here. Let's put them roughly right. Well, I thought the other one was shorted. This one's in you go. Come on. Did it go in? Is that it? I didn't feel it go ka-chunk. But it seems to be held. Okay, must have gone in. Next one is the very same way. The very same way. I'm going to hold this like this. I'm going to stick this guy in. Two is tough. 3 at a time is really tricky stuff here. Oops. Tricky for me. Once again, I didn't really get the feeling. Oh, maybe there. Yeah, there, that went in. Okay, I think that's in. There's a problem right there. How do you know for sure these are in all the way? Okay, last one. The emitter. I have my hands on the emitter. So the long leads here are going to act a little like antennas. So we might get some undesirableness out of this long lead thing. And this guy's, the leads are all bent all funny here. Okay, a little close look now. Is anything shorted in here? Looks good. Okay, and aside from using the camera, let me just take a look with my own eyeballs. Everything looks good. Okay. So we think we have working transistors in here. The few tests I did on the componentry around these transistors indicated everything was okay. I've gone and put transistors into the side we're not testing. Maybe that was a mistake. I'm not sure how I can check the transistor supply voltages without the transistor in there drawing current. So if I want to look at, what is the actual VCC that's showing up, I have to have the transistors in. So I think we're best with the transistors in. So what are the chances here? There's a good chance I'll turn this on, it'll work. So I certainly need an input signal. There's a good chance that's going to happen. Okay, I think that's the ground. This one's a signal on this channel. Okay, let's turn it on. Make sure we got something coming through. So this is supposed to receive a very low signal from the record player, 3 millivolts, which is a very low signal. And that tells me the cartridge is magnetic, and I also know from reading it's very low impedance. Very low level signal, very low impedance. So low impedance hopefully blocks the noise, or avoids the noise. Because there's quite a long wire from here to where the cartridge is in the jukebox. Okay, now I am hesitant, of course. Why not? Should be hesitant. Okay, so this is actually plugged in. Shame on me, having left it plugged in. Power situation looks good. 6.3 volts. Let's bring it on. Okay, so we got the 6.3 volts heating up all the small tubes. And this is nothing more than an ear test. We're at 800 hertz. That sounds just a little low. Let's just. How about 19? How about 1800? That's a little high. Yeah, 1100, 1200. That's beautiful. 1200. Volume is down, I believe. Pretty low. Speakers connected. We're ready. Are we ready? New transistor test number 1. There's some equipment I should have hooked up here to spot right away if there's something going wrong. No. With transistors, by the time you spot something going wrong, it's gone wrong. I think is kind of the situation here. And I still have 2 more spares. Okay, let's do it. That's it. I can't think of any reason not to. We're going with the dim bulbs first. Let me just stand back. We have done it. We have hit the switch. Oh! Power off right away. Well, that was pretty good. Even though I turned the power off. That sounded to me like overdriven input, and that's quite likely the case. So I'm going to, I'm all excited here. Hey, let's drop everything. Down on the signal input. Put these pads in. Now the signal's very low. In fact, it's nil, virtually nil. So we're going to turn the power back on. It's just the high voltage, by the way. Here we go. Hot diggity dog. Now, how do you know for sure we're hearing it? Oh, thumbs up all the way. Fantastic. A little dirt in my control here. Let's give it a little bit of first, I don't have full power on it. Should we try reading VCC now without full power? We will not. We will give it full power. Well, that sounds, it's quiet, but it sounds really good to me. Let me turn this guy up a bit. here. So I don't know if that's 3 millivolts or 30 or 300. I don't know. Sounds great though. Now the actual volume control. Thing of beauty. And we'll just check the frequency range quickly here. Okay, so that's 120 hertz. Oh, that's doing a beautiful job at 80. That's 80 hertz. 70, 60, 50. I can still hear 50. Okay, she's all there. And then on the high end of things, so I can hear that myself. It's 10,000 hertz, and I can hear it, or maybe I'm hearing 5,000. It could be something like that, but. Excellento. Hey, how hot are these things getting? Let's just check that. And did you hear that Italian I just threw out there? Isn't that something? I didn't know I could speak Italian, eh? Hey? That's Canadian Italian. Oh, something's getting warm here. What's getting warm? Not the transistors. Okay, so that's the tubes. The tubes here, you can see getting warm. Transistors, let me just get it really clear shot of it here if I can. It may not be in focus here. So we're looking right down on the transistors, and there's literally no heat in them at all. You can't beat that, I don't think, except we will do the finger test. Now I find the back of my finger in here to be more sensitive to temperature than the pad. Zero heat. There's nothing in there. There's nothing in it. Well, I think that's it for today. In fact, I think this is good. We have jumped a huge hurdle. It could well be load proper tubes into the rest of the amp. The whole thing's working, even as you see it, with all those old capacitors and everything else. That could be where we're at with this. We could be essentially done. Fantastic. That's fantastic. Okay. And that's it. Thanks for watching. I'm going outside. It's another super beautiful day outside. My gosh, this has been one of the best summers I've ever experienced. Hot sun, blue sky, cool air, breeze, everything you can ever want. Fantastic. Actually, you know what? I'm going to show you a little bit of that. Well, maybe I'll make it a separate video. My wife and I took a little trip and we saw something interesting, and maybe I'll make a separate video of that. Thanks a lot for watching. I'm all happy now. I'll go spend my day. You spend yours happy too.